This guy spent 6 months trying build systems in C++. And to this point, I wonder if he found the best build system. Because that will help make tutorials for the future. Most people use CMake, but they also don't like it too much. So I think this would be very interesting to talk about. Time well spent. Link it. I'll link it after the video, yeah. Let's see here.
6 months, countless builds, and me stuck in a loop doing the same thing over and over, using different build systems,
It's a bit
so
loud.
you don't have to. During that time, I put the most popular C++ build systems to the test. So
I think everyone uses CMake, yeah.
the CMake, Make, Meson, and a few others. Some were great, and others frustrating. You want to know which build systems could save you time and sanity, and which...
Oh, okay, so guys, in chat. Type 1 in chat if you think CMake is frustrating. Maybe we should do it differently? Oh my god. So many? Goodness, even on YouTube. Okay, wait, I need to ask you again. That was the wrong question. Type 1 in chat if you think out of the build systems you see on screen, which, by the way, I don't know what the green one is. CMake is the most frustrating build system out of the ones you see right now. Type 1. I just want to gauge how many ones I get. 0. Thank you, Mr. Creator. 2. Visual Studio is worse? Yeah? Really? Wow. Very few people think that. Interesting. Crazy. I thought I'd get a bunch of ones. Huh. I've not seen the... Wait, GCC is worst? Really? They're all terrible? Yeah, Mr. Travis Roman, I wonder if he put a shell script in there too, because I love shell scripts. I know you do too.
ones to avoid.
Let's see.
Let me show you what I've learned over the last 6 months.
Okay.
Let's do a quick tour of the build systems first, and then I'll tell you some of the lessons that I learned along the way. So I used CMake as the reference for all the comparisons.
Smart.
And that's mainly because it's my current go-to for new projects and I know how to use it well. If you're not familiar with CMake, it doesn't build the code itself. Instead, it will generate a build script for your compiler's native build tool. And then that build tool will do the actual build. Why do it that way?
Why?
Well, it allows you to have one script, yet use the best compiler toolchain for the job on each operating system. So on Windows, that would be Visual Studio's Visual C++ compiler. On Linux,
you still have sometimes you still have some platform specific code in a CMake list file. So this is what I do not understand about CMake. Maybe you guys can clear this up for me. If you're using CMake, you still have to use platform specific code in the CMake file sometimes. Why? Why is it not completely platform agnostic? I don't understand that.
you're probably going to use GCC and so on and so forth. CMake is by far the most used C++ build system on the planet,
It's everywhere.
which makes it the de facto standard. Now, there is a lot of anti-CMake hate out there. I used to kind of hate it too.
You used to.
It's improved a lot over the decades, and once you know how to use it, it's very powerful. And simple tasks are actually easy. So here is a simple multi-file hello world. It's just basically an example. It's deliberately been split into multiple source files to demonstrate how
Please don't tell me you use Glob, bro. It's slow.
to compile multiple source files into one program. And with CMake, you can do that in 3 lines.
Okay, so he's compiling main CPP and hello. This is what I don't like. You have to do it on the compiler too. You have to put in all of the CPP files in here. You have to type that.
There's this, you choose
If you forget a CPP file, it's not compiled.
your minimum CMake version. Don't actually need version 3.24 for this, but who cares? You give your project a name, and then we create it.
By the way, that's the reason why I use just one game CPP file, you know? Right now, we're sitting at comfortably 28,986 lines of code. So I only have to put in the game CPP file, because I don't split it up into multiple files, aka I don't have to supply multiple files in there. So I can't forget a file.
With the hello world name, and we add our source files. So very easy to get started with. And now here is a build script for it's a more complicated script. It's not actually a more complicated program. This is a program that uses the Raylib library, which is a cool little multimedia / game library.
We did that
to open up a window and print a hello world message there.
Yeah.
So what this longer script does is
he uses mscripten. Okay. Wow, that's big. Holy. Fetch content. So this is where he's loading in the dependencies from Raylib. So basically, if he's on, I explain that. Maybe he's explaining it though.
It will actually fetch Raylib from the internet and build it for you if needed.
Yeah.
Which is and then link it to your program.
The reason why you do this, I don't think he's going to explain that. If you're on Mac, it downloads the correct Mac version. If you're on Windows, it downloads the correct Windows version. If you're on Linux, it downloads the correct Linux version. Sorry. And so then it builds that correctly for that platform. That allows you to have this one script on different platforms. So someone want to start using Raylib, they can just download that script and get started immediately, which is amazing.
This is great because it means that this will compile out of the box so long as you have an internet connection.
Yep.
Now, how can we...
But I think this file is still too much. Look at how long this file is. I want to show you something. I don't want to... Let's compare, okay? I have made a project in C++ or in C, and we had to build a CMake file for that too, CMake lists. This is the minimum CMake file that I came up with. Version, C or C++ standard, fetch content, one executable, link Raylib, and then telling the target to output into the folder instead of the build folder, because I don't like putting my executable in the build folder. If I have assets as a path here, I want to go straight from the executable into assets. I don't want to have some weird links in the executable. I think it can be done faster, easier. I think this is the minimum that you can have. But anyways, let's continue.
And then link it to your program.
It's still very useful to get started.
Because it means that this will compile out of the box so long as you have an internet connection.
Yeah.
Now, how can we compare the build systems fairly? I think the fairest thing to do is to try to build the same code using all of the build systems.
Yeah. And how long and how annoying is it to set up a build system for the same project? Exactly. Smart.
Exactly what I did. I tried to make each build system do the same thing within reason. So build the multi-file hello world, and then fetch and build Raylib if needed, and then build the Raylib example. So
wait a minute! You know, you guys, you have been telling me how long it took me to make a build system for the C++ and C tutorial that is now on YouTube, where we build a game in Raylib. And you were styling on me, making fun of me, how it took me 2 days to get it done? This guy spent 6 months. 6 months. And you're making fun of me for using 2 days? Huh? What are you talking about? Where is the skill issue, huh?
The first build system that I compared to CMake was good old GNU-Make, which is part of the GCC compiler toolchain. And what struck me the most with this one was just how much more code was needed to achieve the same thing. So let's start with the...
That's a make file?
The first example of the basic 2-file or 3-file hello world, 3 lines in CMake, and this is the make file equivalent. So you can see way...
Sorry. Excuse me, sorry. Oh my god. Oh my god. Okay, that's why people don't use make files.
3 lines. Now you can do it in less, but not if you want equivalent functionality. So this build script has little bits in there to handle the dependency and incremental building feature that CMake has built in. So what that does is the
incremental builds. Yeah, so I see. Yeah, incremental builds are much more difficult to set up in a build script. And CMake just gives that for you, which is a huge advantage. I'm on top of him. I'm terribly sorry. I'm sorry, my friend. I'm on top of you. Where do I put myself? Next to you? Here, maybe. I'm so sorry, man.
Say I change the hello.h header file. It will then intelligently rebuild all the files that reference hello.h. And likewise, this build script can output debug and release builds, each in their own directory, just like CMake can. Now, when it came to the second example, the one that links
Wait
to
a minute.
Raylib,
Wait, so in order to set this up, generate list of compiled object and dependency files. Aha, okay. So if it's already, and then it uses the timestamp, probably, the object files. I would assume it's using the object files and then the timestamp. Are you sitting on his lap?
Cannot fetch and automatically build external dependencies, at least not on its own. It's not built in. It's built in with CMake. With Make, you can, of course, do pretty much anything with external tools and external scripts. So I did that just for the exercise. You'll see that I have this raylib.mk in a third-party directory, and I added scripting code in to detect if the Raylib library is missing and then download and build it using a few external tools. But by and large, Make does not do that by itself. Now, you can use Make for multi-platform development, but you're pretty much limited to one compiler. If you try to run multiple compilers, which each have their own command line parameters, it'll turn into an...
What are you talking about, bro? Like, setting up multiple compilers with CMake was a pain too, okay? We spent multiple hours on that, and that did not work. So, no, bro, it's the same in CMake too.
On the plus side, Make does give you very fine...
I kept using the Windows compiler every time, and people told me, oh, Cakez, you need to use Ninja so that CMake uses the Clang compiler. You can't just use the Clang compiler directly in CMake. No, you need to use Ninja. How? Why?
Brain control over how each file is built, which is great if that is something that you need. So you can watch the full CMake versus Make video. I'll leave a link to that below this video.
Meson.
The next build system to compare was Meson, which was the most requested comparison, by the way. So Meson is a relatively new C++ build system written in Python. Its popularity has grown fairly rapidly, and I think you'll see why soon.
I wonder.
And it has a pretty vocal fan club.
Project.
So like
sources.
CMake, it doesn't do the build itself, but generates a build script for your compilers.
Should we? Oh, it generates a build script.
Native build tool, and then that does the build. So same advantage is...
Why did no one create a build system that doesn't generate these stupid build scripts, but it just builds? Like, how does Odin do it? Odin is supposed to be able... Odin can do it, Zig can do it. Why can't they do it? I don't understand. Why do we need an intermediate build script? Why can't they just do it like this?
CMake in that respect. And I have to say, I like
Zig can do it.
Within half a day, I had replicated both build scripts. So fairly easy. You see here 3 lines and...
He took half a day to make 3 lines of code. What do you say for yourself, chat? Half a day. You know how many hours that is? 12. And now you'd be talking about me skill issues.
CMake, 3 lines in Meson. Actually, you can probably do this in 2. You can do this in 2 lines. You just don't bother writing this to sources. You just put sources straight in here. The Raylib example, fetching Raylib, that is, of course, more complicated on both counts. Here's the build script for CMake.
Yeah.
And then with Meson, it's split in 2. So here's the main build script.
You
can see there are some additional things that need to be done to work around some Raylib
20 lines of code.
Specific platform issues. And then over here, the
dependency
Raylib.wrap, additional things that need to be done to work around some Raylib and specific platform issues.
Bro, CMake is winning at the moment. I'm telling you. CMake's gonna win.
Over here, the Raylib.wrap, which
Thank you for following, Andrew, man. Appreciate it.
This tells Meson where it can fetch the Raylib source code if it needs to download and build it.
Bruh.
So the documentation for Meson isn't the best. I did have to scour the internet now and then to figure out how to do things, which is no different in CMake and some other build systems, really. So on the whole, it was pretty good. If I were to pick something other than CMake for a new project, I think it would be Meson. I'll leave a link to the comparison video below. In fact,
What about the other ones?
I'll leave a link to all of the comparison videos below. Next
Ninja.
up, I looked at Ninja. And
Don't use. Ooh.
This is a build system that you should not use. Okay, you should use it, but not directly. Ninja's own designers explicitly tell you that you're supposed to generate Ninja build scripts using another build tool like CMake or Meson, not do it by hand. Now, I did do it by hand for just the basic Hello World example. And these 3 lines turn into...
This guy has like 40 lines of code for a 3-line of code CMake file. What? How? How do you even put that many words into these 3 words?
This script here. So you can see way longer. The reason why you shouldn't write the build scripts by hand is because they've sacrificed programmability for speed. Their primary goal is speed. Ninja is fast.
For those of you who compiled Sprite using Ninja, it takes like multiple minutes, almost like 20 minutes to compile this program using Ninja. How can these guys be talking about speed? What is that called, speed, man? That's not speed. That's a snail.
Fast, especially with incremental builds, which is why you do want to use it. But they achieve this by removing all the fancy pattern matching and programmability that actually makes build systems easy to use. So have a look at this. This is the build scripts generated by CMake for the Raylib example. And you can see it just keeps on going and going and going and going. You do not want to be writing something like this by hand.
I can see why this guy took 6 months. This guy spent 6 months on this file. Holy.
It is a bit more verbose because it was generated by CMake.
I don't think Sprite's build times are Ninja's fault. Yeah, I agree. It's probably something that Sprite does. Yeah.
Verbose than it's needed.
Still funny.
But really, you don't want to be writing this by hand. So take the advice.
See, like, you know how Mr. Jonathan Blow is angry that his compiler takes a second to build his entire thing? And he's like, we need to make the compiler faster. He's complaining about a second build time, and we're talking about multiple minutes with Ninja. Don't use incremental builds in big project. You don't have the frame of reference. Ninja is way faster than MS Build. Yeah, I would assume it is, yeah. We'll have to see how, like, a huge project would look in a Unity build. We'll have to see.
Of Ninja's designers, and you use Ninja via CMake, Meson, or another build system that supports it.
Visual, oh god,
Ninja,
okay, easy.
I built the same 2 projects using...
I want to quickly chime in for the Visual Studio stuff. Everyone starts with Visual Studio to make games in it. What I don't like about Visual Studio is that it opaques all of the options away from the command line into an interface where you just have to tick boxes or change certain letters into different numbers or into different, into different options. And in my opinion, it takes away what C++ actually is from you, and it makes it very difficult to understand what is happening in the background. And then when you are out there somewhere and you need to make a C++ project, you can't even do that.
Visual Studio itself. And this was easy. Visual Studio is really beginner-friendly because you don't have to write any build scripts at all.
Yep.
You use the GUI to add the files to your project, and then Visual Studio takes care of the rest for you. It also has a package manager called NuGet, which you can use to fetch libraries such as Raylib from the internet. So long as somebody has created a NuGet package for it, it's easy. On the downside, you are locked into using Visual Studio for building.
I think that's fine,
which is fine if you only want your software running on Windows. If you want your code to run on multiple platforms, however, then you really need a proper build system like CMake.
Wait, you need to... Wait, you cannot build to other platforms using Visual Studio, is that correct? So if you want to make a game for Linux, is not correct? Of course not. You can. You can't. What are you guys talking about? Yes or no? MSVC and MS Build are winners only. You can. Visual Studio has Clang. You're right. You can implement. You can download Clang with Visual Studio. You're right. Yeah. It's a different setting of the project creation. I see. Okay, so you can. Okay. Okay. Good stuff. So you can build to Mac maybe, and you can build to Linux, I would assume.
So the last build system I tried was Bazel, and Bazel's design goals are very ambitious.
Bazel?
They want it to
Never heard
be
about that.
fast, multi-programming language, multi-platform, scalable, and extensible. So basically the build system to rule all and end all build systems. Very ambitious, as I said. Alas, my experience with Bazel was not so great. From the get-go, to install it on Windows, I had to install Choco, to then install Basilisk, which would then install the latest version of Bazel.
See, when I would see this online, I would quit out of the website and call it a bad build script and never touch it again. If a build script does not offer you a click download button, then it's bad, in my opinion. Sorry. Programmers just think too complicated.
Needlessly complicated.
Yep. True.
And I hoped it wasn't a sign of things to come. Now, the first Hello World example, that was easy. Here is the Bazel script for that. Nice and simple, although for some reason you do have to have this empty module.bazel file as well, or it's not going to work. And then,
who wrote this? Sorry, but we're not going to be mean though. Okay, that's weird.
Things fell apart when I tried to replicate the Raylib example.
You couldn't?
So there I encountered cryptic error messages, poor documentation. Scouring the internet didn't work. I worked late into the evening to try to get the Raylib example working, and I ended up going to bed really late, tired, and very frustrated. So then in the morning, I decided to
sounds like me trying out Zig.
Try again on Linux. And this time I got it working, but only on Linux. And as you can see, now this time the module.bazel file does have content in it. This is where you fetch Raylib if needed. And
you need to put the SHA key in there? It's probably the public key. What is this?
Got this little Bazel RC, and then the main build file is somewhat longer. So I did get it working, but only for Linux. Clearly there is a bug that is preventing it from working on Windows. All of it really reminded me of the way CMake felt a few decades ago.
Just a hash?
Which means there's hope that it'll be a lot better a decade or two from now. For now, though, I think I'll skip it and stick with CMake. So, out of all of these build systems, which would I recommend?
What happened to GCC? Did he talk about that? Did he skip over GCC? Do I have memory loss? Huh? Did he skip over this? That was Make? Oh, I see. It's so bad. Okay.
Well, if you're just starting out with C and C++, then Visual Studio and Xcode are probably the easiest options. Yeah, although I highly recommend that you move on to using a proper build system ASAP, because it really is useful.
Yep, it is.
After that, I recommend learning CMake. If anything, it's so common that you're going to encounter it sooner or later.
Yes.
And being able to use CMake is a useful skill to have.
Unfortunately, you have to use it, which is so sad. It's just sad, because it would be so cool if you could just compile C++ out of the box like Odin or Zig. These two languages are so great because you can just, and J too, you can just compile them using their compiler. You don't have to do anything else. You don't have to download anything. It's amazing.
After that, I think Meson is the most promising, and Bazel might be awesome a decade or two from now. I would only use Make in projects where I really need that fine-grained per file control.
Yeah, so that would be advanced.
You know, I haven't really had any need for years. Or if I'm building for a platform that doesn't support CMake. So that's all the build systems covered. What else? Oh yeah, if you want the source code and the build scripts for everything that you've seen in this video,
The Relic one is
then
nice.
you're in luck. I've put together a summary document together with all the code and build scripts that I wrote for these comparisons. The summary also mentions build scripts that I have not covered in these comparisons. Anyway, they're
Learning
available to
curve
download
medium.
in Here Campus for in these comparisons.
CMake, learning curve medium. CMake, hard. Yeah, I see that. Multi-platform, no. Yes, yes, yes. Visual Studio is not multi-platform. Okay, have tried. Okay, Meson, medium, Bazel.
Anyway, they're available to download in Here Campus.
Unknown. Why did he not go and try pre-make out? Wait, shouldn't he have tried pre-make? I'm confused right now. Shouldn't pre-make be on the list? Maybe it's coming later?
Creator and higher tier members.
Why did you not try pre-make?
Wait, I realize that not everybody wants to sign up to a membership program. That's partially because some big bad companies have been holding their subscribers hostage and making it almost
Okay, bro. What are you putting up here?
impossible to cancel. I won't do that, by the way. Anyway, to cater for those who would like the summary and all the build scripts and stuff, it's available as well for a one-time purchase. Link in the description below. Go get it there. You can use the example code as templates for your own projects and support this channel at the same time.
What
else have I learned? First, C++ build systems really have come a long way over the decades, although they still kind of suck.
No, they have not come a long way. I don't see a change. They all suck. They all suck, man. I don't see a single perfect build system. It's not. If they have come a long way, we would have a build system by now like Zig or Odin. That's a hill I'm gonna die on.
Just ask anybody who's switching to C++ from a newer language. There's still lots of room for improvement, although I think that a fair bit of the build system pain is self-inflicted. More on that later. I discovered that once you know one build system, learning another becomes easier. That's because you understand what their purpose is, you understand what they can do and how it's done. So getting a new build system to do what you were doing with the previous one gets easier, although you still need to factor in that each build system has their own way of working. Third, a good build system is one that gets out of your way and allows you to focus on writing code.
Yeah, true.
While comparing the build systems was interesting, doing the same thing over and over
is annoying.
With different build tools reminded me of just how precious my time is. I want to write awesome software, not fight with the build system. And over the course of this comparison series, I grew to kind of resent comparing yet another build system because I'd rather write actual code. Finally, the whole experience has reinforced my belief, my strong belief in making and keeping things simple. You can help this build system.
So I would have loved if he went over and did this too. So this is a CMake file, right? We saw that, and I think that's the best place to start as a developer getting into C++. I would have loved if he went over and did this as well, though. It's not cross-platform. There are ways, though, that you can get cross-platform kinda-ish code running. So this is a build script that I wrote for a Unity build system that builds my game. And now you can see that there's a lot of options here, but that's the extent of building it to 3 different platforms: Linux, Mac, and Windows. Rally build, .NET build. And I would have loved to see a pre-make build too. I wonder why he didn't go for that too. Why not?
Get out of your way by keeping things simple in the first place. As with every other profession, programmers can be quick to blame their tools. But the build system isn't the one that decided to add 100 build options. Nor...
Your tools didn't create the mess, you did. Well, who added the build options then, though?
Was it the build system's fault that you decided to add all these complex build rules?
I see.
You mean...
He means defines that change based on. So, for example, you can have a debug build system that allows you to build the game in an engine and have your own editor in the game. But in a release build, you don't want the editor to be there because you don't want the player to interface with the editor and stuff. I get it. But I think that's the extent of it. It's just to define. What else would you need as a build system? What else?
Who bolt system on top of system and then hide the complexity underneath and then complicate things in order to look smart in front of our peers. Expecting the build system to first enable creating a complex mess and then clean it up for us is stupid. I've long been an advocate for putting energy into making and then keeping things simple. Simple systems are easier to build, they're easier to maintain, they're more reliable because there are fewer things to go wrong. So actively look at what you can remove, not just from the build system, but everything in general.
True.
Simplify requirements before implementing.
So it's a Western mentality to add things to a problem. So for example, when we tried to run Clang in CMake, people told me to download Ninja. In my opinion, you shouldn't need a third party to run Clang in CMake. You should be able to run Clang immediately out of the box with CMake. You should be able to tell CMake, use Clang as the compiler and not the other way around. So not have to download one more thing. That adds one more thing to the problem. It's a Western mentality where you add more things. So for example, a big thing on that is beauty. You have a lot of beauty products that help you fix problems that beauty products create. So for example, you use shampoo, your hair is dry. Now you use, what is it called? Now you use wax to make the hair so that it you can keep the hair in place. If you don't use shampoo, you don't need to use wax.
Them
okay,
because
that works.
Nothing is a bigger waste than implementing something that shouldn't exist in the first place.
CMake is a build system.
Always
isn't a build
ask
system?
if something is necessary. Every feature needs to earn its place. Every added complexity needs to be justified in the value it brings to the overall product versus the complexity that it adds. You should be actively looking at what you can remove. A quick reminder that you can get a summary and all the example code for all the build systems in this video. Link in the description below. Get it, use the templates to write awesome software and support this channel at the same time. Everyone wins. Or if you want to watch the entire build system comparison series, then click the playlist over here. That's it.
But what about CMake, bro? Why should not use CMake? Comment before watching. My experience of 25 years of dealing with them is they range from bad to terrible. Really, one of the worst downside of C and C++. True. It is. Awesome, who's been relearning C++ recently. What about pre-make? You mentioned CMake versus make video. Do you have a link to it? CMake is horrible to learn. Yes, and use. It is, unfortunately. What about the Zig build system? Oh, this guy knows! The Zig build system. You just use the Zig executable to build for you. Works on any platform. Easy. Fazit. Use the Zig build system. What about CMake? Chat. For those of you who used pre-make, sorry, not CMake. What about pre-make? I know that the Cherno uses it a lot. Is it a good build system compared to, CMake? What is the problem with pre-make? I like pre-make. Uses Lua. Pre-make is okay with Lua for me. If Lua is fine for you. Okay. And pre-make effectively functions the same as CMake. Okay, I mean, it's fine then. Would have loved to see him talk about pre-make too. I'm sorry, maybe it's just dumb. Why do you even have to make C more complicated in order to compile it? Doesn't the compiler make all the complexity needed for the target execution environment? Why doesn't one make a system needed to specify these extra things? See, that's what I mean too. If you have a build script running on one platform and you don't make your build system too complex, you can make a build system in... How much is this? Let's say this is 10 lines of code. This is another 5. Let's say that's 25 lines of code. And then for each platform that you build on, you have about 25 lines of code. Maybe more, maybe less. About that much. And you can program specifically on each platform. And usually when you are making an application in C or C++, you begin with one platform. You don't build to multiple platforms first. If you're talking about the game, you make a game for Windows first. It's just gatekeeping. All you need is either a batch file with one line or Visual Studio with a play button. People who advocate for this for one-man projects is delusional. Yeah, you don't need this for a one-man project or when you're starting to learn this. This is not a build system. This is a build script. And that's fine. Yeah, so what I mean that it still builds the game the same way that the other one builds. Anyways, you wanted to have the video on this. I'll link it to you guys. Give me a second. Where is it? This is the link, guys. And it's a relatively new video on a relatively new channel. So if you would like to support this guy, you can obviously go to the example projects and get the summary as well on his blog post. And if you want to support the video itself, you can watch the entire video again on 1% volume so that you give him the entire watch time of the video and support his channel. And then YouTube supports the video more because it sees positive feedback. So if you want to support him, do that. Otherwise, good video. Would have loved to see pre-make too, but it is how it is. I will stick with my build script or CMake for new projects if you're new. CMake for new projects or a build script for yourself.